Hi, in this video, we're going to walk through the example from chapter 13, which looks at the Bass diffusion model to sort of forecast how sales of a product or a product category have evolved and will likely to evolve over time. In order to do this, we're going to use R to generate our P and Q and market size, and then we're going to forecast. And then we'll go over into Tableau and look at those forecasts. So let's start by going into R. So the first thing we'll do is we'll open up the chapter 13 R code called Bass diffusion. Make it a little bigger so we can see it. Now, as always, the first step is to install any packages and load those libraries if needed. Here, we don't need any, so we're going to go straight to just setting the random number generating seed. Then we're going to read in the data that we're going to use. Now here, we've gone out and collected data on smartwatches, similar to the chapter 12 example with conjoint analysis when we dealt with smartwatches. We're going to load that data up. That'll be the sales underscore data file. Now, this isn't a terribly long file, so if we just type sales, we'll see the entire data set. Now, what we have here is we have quarterly data since the initial release of the smartwatch in 2014, all the way until January of 2020. So with 24 periods, and these were the sales in millions of units of smartwatches around the world. Right? So what we're going to do is see whether or not we can estimate the Bass diffusion model, the P and the Q, and forecast what the future sales of this market might look like. In order to start, the first thing we need to do is create the cumulative sales and lag of cumulative sales variables for estimating our model. If you remember, our model is going to be sales today as a function of cumulative sales last quarter and cumulative sales squared last quarter. So we'll first generate those two variables. Next, we're going to estimate the regression with that I just mentioned, and we'll go ahead and print out the results. So you see here, when we estimate the regression, we get an intercept, we get cumulative sales, and we get the square of cumulative sales. Right now, we could look, we're not as worried about significance levels, given that we're using the lag and the square of the lag term, but we do observe the signs are correct and that the cumulative sales is positive and the square of cumulative sales is negative, which would suggest that we have what will look like a Bass diffusion model curve. The next step is we're going to actually determine what our N, our P, and our Q are, N being the total expected market size that we think will happen for this generation of smartwatches. The P is the innovation coefficient, right? That's the rate at which people adopt independent of others. And Q is our imitation coefficient. That's the rate at which people adopt based on the adoptions of people who have already adopted already. So we can run this section and this will generate those N, P, and Q coefficients. So we can see here our N. So about our total market or sales of smartwatches by the end of this generation is expected to be about 457 million. Our P coefficient, and then we have a Q coefficient. Now, these in themselves don't necessarily mean a lot, other than if you go and look at analogous diffusions of products at their P's and Q's, you could sort of see whether or not this is diffusing similar or differently from other products. So let's go ahead now. We have 24 periods of data, 24 quarters. Let's go ahead and forecast out for 50 quarters, so 26 more quarters. So in this section, we're going to do the forecasts for both sales as well as cumulative sales. So let's go ahead and forecast up to 50 periods. And the result now is we have two tables. One is going to be a forecast of the cumulative sales data, and one will be a forecast of the sales data. So we're going to export those two tables. The first table we're going to export is the cumulative sales table. So we'll go ahead and go into chapter 13. We'll call this cumulative sales data.csv. And the second file we're going to export is the forecasts, which will include the 26 additional data points. So we'll call this sales forecast.csv. Okay, so now we've run the BAS model. We've generated the N, the P, and the Q to give an idea of how things are diffusing. And we've generated our forecasts, which we're going to utilize in our visualizations. So at this point now, let's go over to Tableau. And now we can create these visualizations. So the first thing we're going to do is we're going to open the cumulative sales data. You'll see that it'll bring up the data that we have from that file, which is the period. Now the period in this case runs to 24 periods. And we have the sales, the cumulative sales, the squares of those, and so on. Now, we then want to attach our sales forecast to this data. So we'll drag sales forecast here. You'll see it wants to attach to the cumulative sales data. Now, it doesn't know the column you want to match. So you go down here and you're going to select that on the cumulative sales side, we're going to match, I believe, using period. And on the sales forecast side, we're going to match using T. And when we do that, we find that it does find some matching data. So now we have the data, the two tables loaded up. Let's go over to sheet 1, where we're going to create two different visualizations. The first visualization we want to look at is the actual versus predicted sales by quarter. And then we'll look at the cumulative versus predicted cumulative sales per quarter. So the first thing we want to do is let Tableau know that this T variable is representing time periods, and we're going to treat it as a dimension rather than a measure. So we'll right-click on T and say convert to dimension. All right, so then we're going to go ahead and drag T over to columns. Right, and now we have the 50 quarters that we're going to either have the data or be forecasting the data for. Now, in this table, in this figure, what we want is we want the we want the actual sales data. So I'm guessing we want to drag sales to rows, and then we're going to drag predicted sales or forecasted sales to rows. And we'll see we get two tables, two figures here, one for each. First thing we can do is if we want to see it less as a bar chart, more as a line chart, we can just change it from automatic to line. So that'll give us the smooth line in the case of our forecast, at least. The next thing we want to do is overlay the two charts on top of each other so we can see how the actual versus the predicted sales look. So let's go ahead up here and click the down arrow and choose dual axis. So we can see now it's going to overlay the two on top of each other. Now they're on different, they're not synchronized axes. So we're going to go ahead and right click on the axis and choose synchronize. So now they're at the same levels of sales laying on top of each other. If we want, we can go ahead and get rid of this indicator so that we don't see it on the chart. And lastly, we can go ahead and change the name of this figure to actual versus predicted sales by quarter. So what do we see? Well, we see that the actual sales are not as smooth. They jump around. In fact, if we look at the quarters, the tendency seems to be that it is seasonal. that sales remains at some level, and then during certain seasons of each year, most likely holiday seasons, we see a jump in the sales of the smartwatches, then it reverts back, and then it slowly builds up and jumps, and then so on. What the forecast is doing, the BAS model is doing, is it's taking a smoothing of those sales. So you can see how this blue line sort of runs in the middle of those, and then eventually levels off, and we see a decline. So what this is telling us is that we're not quite at our peak sales number. That seems to happen somewhere around quarter 27, right? And we still have some sales to go. So even though sales are declining, we're still selling millions of smartwatches worldwide. And so there still seems to be quite a bit of market left for us to be able to capture if we decide to enter the market at this point. So that's our actual versus predicted sales per quarter. Let's go ahead and open a new sheet. And in this new sheet, we can do the same thing, but this time we'll do it for cumulative sales. So we'll go ahead and drag T over to columns. Here we're going to drag cumulative sales to rows. We'll drag the predicted or the forecasted cumulative sales. Again, we'll see two charts. Let's go ahead and change it from bar chart to line chart. Let's click here on next to cumulative sales and change it to dual axis. Again, these are not on the same scale, so let's right click and choose synchronize. You can see how it lines up now nicely. We can get rid of this indicator. Right, and now we can finally add the title here. So this is actual versus predicted cumulative sales per quarter. And so now what we can see here is actually when we aggregate the data across all of the quarters and build this cumulative measure, we see here that it smooths it out. And in fact, our model is doing a pretty good job of capturing the cumulative sales change over time. And again, we're sort of at not quite at the inflection point, and then we'll start to see a decline in the rate of sales up to the end. Now, if you remember, our N was about 457 million. Here it looks like after 50 quarters, we're coming in just at around 439.6 million. So we still have a little bit of sales after quarter 50, but it's at that point getting to be a small number per year. So one might assume that at some point around here, we might see new generations of smartwatches to sort of restart this BAS diffusion model curve. So lastly, we're just going to save this. So we'll save as, we'll save it as a packaged workbook, so it includes the data, and we'll call this BAS diffusion. So what you saw in this example, in R, we estimated the BAS diffusion model. We recovered the market size prediction, the P and the Q coefficients. We forecasted the sales up to 50 quarters from the 24 that we already had. And now we can visualize both the actual sales per quarter as well as the cumulative sales per quarter of what happened versus our forecast to see how good our forecasts were.